Hi friends, good evening. So welcome to the Automotive Analytics training by 360DigiTMG. So in the previous session, we discussed about K nearest neighbor, and in previous class we also discussed regarding machine learning is classified into two types. So unsupervised learning and supervised machine learning. Yeah. So supervised machine learning is a types of machine learning in which we will apply on label data. So on the base of the data, machine can predict the correct output. So in supervised learning, so training data is provided to the machines to work on the data. So in this supervised, so input data as well as correct output data to the machine will be provided. The aim of this supervised learning algorithm is to find the mapping function to the input variable to the output variable. Just briefly, I can explain how it will work. So as I explained, so in supervised learning, so models are trained using the labels data set. So where the model learns about each type of data. So once the training is done and testing is performed, then that will compare accuracies. So I can give some examples regarding supervisor. Suppose we have the data. Suppose we have the data, so which includes squares, rectangle, and triangle, and etc. Now the first step is that we need to train the model for each type. If the given shape has 4 sides, we can say it is square, and the given shape is 3 sides, we can say triangle. Then if the given shape has 6 equal sides, so it will be labeled as a hexagon. So now after training, we test our model using the test set, and the task is the model is to identify the correct shape. So already machine trained on the types of the shape. What are the various types of the shape? So now it find the new shape, it classify the shape on the base of the number of sides. So this is one simple example for how supervised learning will work. So let us discuss about, so what are the steps involved in supervised learning. So first of all, we need to define the type of training data set. Type of training data set. And collect and gather the labeled training data. Collect and gather. Then split the training data set into the training data set and test data set and validation data set. So then we need to determine the input features of the training data set, which should have the enough knowledge so that the model can accurately predict the output. And after we need to determine the suitable algorithm. We have various algorithms in the supervised learning, such as like classification model or regression model, etc. And execute the algorithm on the training data set. Sometimes we need validation set. Validation is nothing but first testing data is comes in validation data, and evaluate the accuracy of the model. So based on the good accuracy, we can say. And as we discussed, the types of supervised machine learning algorithms are two, that are regression models as well as classification models. So yesterday we started with the classification model, discussed about K nearest neighbors. So today we are here to discuss regarding decision tree. So what is decision tree? Let us discuss. Yes. So as to today's agenda, we will discuss about introduction to the decision tree, how decision tree will work in machine learning, what is decision tree in machine learning, and how it is important, the importance of decision tree in automotive analytics. And we'll discuss about conclusion. So after this, we will take one use case and we can discuss answer. No. So what is a decision tree? So to understand decision tree, I can take one simple example. So whether you have one offer, so you need to accept or not. You need to accept that offer or not. So that decision you can take. You need to take the final decision based on some features, like so what is the salary they are providing, what is the distance, any incentives, etc. So in our daily life, so decision tree plays an important role. So for every decision we can think, and there will be some features will affect our decision. Now in machine learning, it is as I explained, as I said, so it is a supervised learning technique. So it is used for both the classification and regression problem. So classification models we use if our output variable is categorical. So like yes or no, accept or not accept, like that. So regression is nothing but if your output variable is continuous values, so we can use regression. The decision tree algorithm, so it can be used for both classification and regression problem, but mostly it is preferred for solving classification problems. And it is called a decision tree because it is similar to the tree. So it starts with the root node, the basic, so which expands on further branches and construct a tree-like structure. So a decision tree simply asks a question and based on the answer yes or no. So it further split into the subtree. How what is decision tree machine learning? So in decision tree for predicting the class of the given data. So we are discussing decision tree concept in classification problems. So whenever if we have the data, so the algorithm starts from the root node. So we can consider the one feature, and the algorithm compares the values of the root attribute with the record. I mean, that is record is nothing but real data set attribute, and based on the comparison follows the branch and jumps to the next node. And usually this decision tree mimic human thinking ability while making the decision. So it is easy to understand. The logic behind the decision tree can be easily understood because it shows tree-like structure. Now, let us understand the terminologies in the decision tree. So it is like a tree structured classifier. That's why it is called as decision tree. And where the internal nodes represents the features of the data. And branches represent the decision rules, and each leaf node represents the outcome. So after leaf node, you cannot get anything. See in the picture, it is clearly saying decision node. So where we need to think, that is also called as root node. It further split into decision nodes. Then the decision node again split into leaf nodes. That is ending point. And this decision node and leaf nodes, so this should be considered as subtree. Same again, that node is converted into the leaf node and decision node. Again, further decision node is split into leaf node. So why do we need a decision tree? Suppose there is a person who want to buy a new gas type automatic car. So to solve this problem, the decision tree starts with the root. So whether the person, the person has to purchase or not. So he is interested to buy a new gas type and automatic. So you can see the picture. There is a car. The person intention also to purchase car. So it is classified into two categories. So it will work manually or automated. So once if suppose if it is manual, the person will reject. So will not purchase that. Suppose if it is automated, again there will be two questions. So it will run with gas or diesel. So his intention is nothing but he want to purchase car with gas type. So if he selected diesel, he will not purchase. Again gas. So it will work with gas or not. So if it is yes, definitely he will buy. Otherwise no. So in this way, so decision tree will work. So let us understand some some concepts in decision tree. So first is entropy. So what is entropy? So it is an information theory. It is an information theory metric that measures the impurity or uncertainty in a group of observations. So entropy is nothing but information theory metric. It is a metric that measures the impurity or uncertainty in a group of observations. If we have the data set, so do we have any uncertainty in the group? So that is nothing but entropy. Next, what is information gain? Generally, we will discuss information gain. So it is defined as the amount of information improved in the nodes before splitting them for making further decisions. So it is defined as amount of information improved in the nodes. So before splitting for making further decision, how much information it is giving before splitting. And we will speak more regarding gene index. So what is gene index? So it is also nothing but gene impurity. So it calculates amount of probability of a specific feature that is classified incorrectly when selected randomly. So it is that calculate the amount of probability of a specific feature that is classified incorrectly when selected randomly. So generally these values ranges from 0 to 1. So if it is 0 is purity and impurity is nothing but 1, and so 0.5 represents so equal distribution of elements. So while we are going to apply decision tree, so we need to consider this. So entropy, it is information theory metric, measures impurity or uncertainty in a group of observations. And information gain, it is defined as the amount of information improved in the nodes before splitting for making further decisions. So gene index nothing but gene impurity. So it calculates the amount of probability of a specific feature, so that is classified incorrectly when selected randomly. So ranges from 0 to 1. So 0 it is nothing but pure, 1 is impure. So 0.5 is nothing but equal distribution. So let us discuss how decision tree will work in automotive analytics. So generally to make decision manually, it's time consuming and labor intensive process. So just you can take one. So I want to purchase one car. So there will be some cases. So a car I need to purchase or not. So what features I am interested. So how much money I can spend. I can spend on this limit or not. If yes, you can. Or what type of fuel I am expecting, etc. So evaluating the conditions of the car, so before purchasing plays a crucial role in decision making. So what are my uses in future? So whether it will reach to that level or not. So that decision. So based on the data, if that suits for us, I can purchase. So I can take the proper decision. So and one more for one vehicle there is a 1,000 parts. For assembling these parts, good decision accuracy should be taken. And Toyota Innova takes 1.6 minutes of time. So using ML algorithm, and it plays an important role. We can leverage machine learning techniques to develop an automatic system for classification related business problem. So in this way, so we'll take a lot of decisions, and Suppose if any manufacturing company, so they can take, so what people are looking, so are they looking these aspects or not? If is this based on their based on this concept, decision tree concept, they can manufacture accordingly. So this is let us conclude. So this decision tree. So decision tree has been found useful in classification and prediction modeling due to the fact it can be capability to accurately discover hidden relationship. So in our data set, if there is a relationship between the columns, it can predict. So between variables, it is capable of removing and insignificant attributes within a data set. So two uses we have, and it can handle, so decision tree can handle both continuous and categorical variables. And execution of this algorithm possible without having to scale the data as well. And while utilizing the decision tree algorithm, it's not necessary to create the missing values. So this is about conclusion. So let us take hands-on. So how we can implement this decision tree through Jupyter node. Yes. So here I can find one data set. So for the data set, I'm going to apply decision tree concept. So first of all, we need to import required libraries. So first of all, import numpy as np. So numpy is a library, so we can work on arrays. And we can import pandas as PD. So pandas for working on data analytics. So if you want to analyze the data, if you want to load the data, if you want to do any operations on data set, so this library is important. And so we are importing matplotlib.pyplot as PLT. So matplotlib.pyplot for visualization, Seaborn also for visualization. Yes. So these libraries are essential to work. And I'm importing OS. I'm taking input from the Kaggle. So let us execute this. Yeah, it is executing. Yes, done. Now I'm importing warnings. So the purpose of warning is while I'm executing the code, I am not interested to see such warnings and etc. I want to ignore that warnings. So just I am importing warnings. Ignore. Now I have one data. So that is car evolution.csv. So already it is in my home page of Jupyter. So I want to load the data. So I can execute this. Done. Now, if you want to see the data, just you can add one column. Just if you write DF. Yeah. So this is the data. So this data set has 1728 rows and 7 columns. Unfortunately, the column names are not mentioned. So it is like 0, 1, 2, 3, 4, 5, 6. So we can add the column names. So df dot head. So df dot head will give the top 5 rows. So next df dot shape will give the number of rows and columns. Now I want to rename the columns. So column names I am considering. So buying or not, mint, doors, persons, leg, boot, safety, class. So I want to rename the columns accordingly. So after just I can df dot columns is nothing but column names. So what are the column names? You can check here. So these are the column names you have: buying, mint, doors, persons, luggage, boot, safety, class. Now again I am checking. So because in the data set initially we are not having the column names. So column names are compulsory. Just I am giving the logical names. Now what is my df dot head? Yes, buying, mint, doors, persons. So luggage, whether it is small, medium, etc. So it is just boots are nothing but independent lug to help you better tread the slip rest of the situations. Like you can shoes are like. So just I want to know the data type of my each and every data type of a column. Just for that, I'm executing df.info. So df.info will give the data type of each and every column. So as you can see, so this data set has 7 columns. So the data type of each and every column object only. Yes. So next for column in the column name, just print df column name counts. The value counts I want to check each and every column. So the value count, so with respect to each and every column, so V high 432, high 432, median 432. So here it is clearly given. The counts of we have around 6 columns. So the value counts of each and every column. So like buying, mint, doors, person. So in that, what type of categories we have? So V high, high, median, low, very high. V high stands for very high, high, median, low. So these are the different. So next, this coming to second data set, mint also very high, high, median, low. no doors, etc. So here I'm getting the counts of the each and every value. Yes. So next, what about the class? So df class value count. Just I'm checking. Yeah. So this class inaccurate, accurate, good, very good. So inaccurate 1210, accurate 384, good 69, very good 65. Now I'm checking, do we have any NA values? I want to know the sum of NA values present with respect to the column. So already we discussed it. So if we have NA values, so we cannot analyze the data. So we need to handle that NA values. Either we can remove that by using drop NA, or we can add the logical value based on imputation techniques. So let us check, do we have any NA values or not. So as you can see, so each and every column is not having NA values, buying 0, main 0. So no NA value present in our data set. So that is fine. Now just what I am doing is I am defining x comma y. So y is nothing but output variable, and x I want to drop class. So we need to predict inaccurate, accurate, good, and very good. So first for x, the df dot drop class. So without class, we are taking x, and y we are taking with respect to the class. Next, let us check x dot head. So top 5 rows. Similarly, I want to check the y dot head. So it is only having 0, 1, 2, 3, 4. Yeah, I think it is giving whether accurate. These are the top 5. And we have the answers like it inaccurate or accurate, good, very good. Now just we are going to the model building step. So as I discussed in the second class, CRISP MLQ methodology, when we have the problem statement, first we need to understand the problem. So what we are going to do, then we need to find out the objectives and constraints. So after data engineering steps, up to now the data engineering steps finished. So now we are going to the model building stage. So in the model building stage, first we are importing from sklearn.model selection. So sklearn also called as scikit-learn. So import train test split. So what is sklearn? So sklearn is a software machine learning library for the Python programming language, and it features various classification, regression, and clustering algorithm. So popularity in ML. So we are importing from sklearn.model underscore selection, import train test split. So let us execute this. It is done. Next, what I am doing is now x train, x text, y train, y test. So we are splitting x comma y. Yeah, so test size, so we can take 0.33, so train 0.77, and we can have random state is equal to 42. So random state, it simply sets a seed to the random generator. So after setting these values, so our train test splits are always deterministic. So don't set a seed, so different each time. So here I am giving random state is nothing but 42. And what is train shape? Test shape, let us check. So here we are doing training on 1157 rows and 6 columns, and testing on 571 rows and 6 columns. So let us check. So X train, X test. Similarly, Y train, Y test. Yeah, 1157 and 571. Now let us check the data types of X train. Yeah, so X train data types. So we have buying, mint, doors, persons, boot, safety. Yeah, same data type already we have seen. So next X train dot head. So training top 5. Next here actually need to import category encoders. So I already installed. So if you are doing for the first time, you can execute this. Yeah, so as I already installed it, that's why it is showing like that. Next, so encode categorical values. So import category encoders as seed. Just let us run. So encode variables with the original encoding. So encoder C dot ordinal encoder. Column names are buying, mint, doors, persons, boot, and safety. So let us execute this. Next, X train head. These are the values. X test head. Done. Now we are going to the decision tree criterion with Gini index. So as I explained, so Gini index, it is also known as Gini impurity. So it calculates the amount of probability of the specific feature that is classified incorrectly when selected randomly. So as I said, these values or varies from 0 to 1. So if it is the value is equal to 0, it should be pure, and 1 is impure. If this value is nothing but 0.5, so it nothing but equal distribution of elements. Yeah. So now what I am doing is I am, and just we prefer generally, this point also very important, we generally prefer least value of the Gini index would get preferred, and this we can calculate by the formula 1 minus summation I is equal to 1 to n p a square, probabilities values, right? Now, so let us import from sklearn.tree, import decision tree classifier. So this we can, so sklearn will support maximum so machine learning libraries. So we need to import a decision tree classifier from scikit-learn or sklearn. Done. Now next what we are doing is CNF Gini, so decision tree classifier criterion. So we are using Gini index. Now maximum depth I am taking as 3, random state it is 0. So maximum depth is nothing but the longest path between the root node and the leaf node. So what is the longest path between root node and leaf node? So let us execute this. Yeah, it is done. Maximum depth I am taking 3. So Y prediction Gini X test. So yes, so we are having that array that consisting of inaccurate, accurate, inaccurate, etc. So Y variable. Now let us check the accuracy score. So from sklearn.metrics import accuracy score. Done. Now model accuracy with the criterion Gini index, that is 0, 0.4, and accuracy score Y predict Gini Y test. So with the Gini index, so the model accuracy is equal to 80%, 80.21. So on training data, so let us check. Yeah, now here I am going to check the accuracy. Yeah. So the model accuracy score with the criterion Gini index is nothing but 78%. And model accuracy with the Gini index train and test, so we can get the values. So 0.8070. Okay, somewhat better. And I want to show in plot. So 10 to 8 scale and import tree. Just I can get one tree. So now you can see. Yes. Gini index 0.45, samples 1157, values. So here you can find the decision tree. Finally, so the tree is split into the two again based on decision node and leaf node. But for 2 decision nodes, again the second decision node again further split into 2 decision nodes, and finally that is becomes 2 leaf nodes. So this is about splits in the decision tree. And so when the maximum depth, here we have chosen maximum depth is equal to 3. Okay, it is okay, but when the depth is increases, number of rules we will get, but that leads to overfitting. So whenever we have the huge columns, so we can find different rules, and it is influenced by the column, so what we have chosen initially. So as we need to select the best attribute, best column, which describes more regarding the data. So that is also challenging. So we can have many rules. So that is also one of the challenge. So with respect to the decision tree. Okay, let us recap. So what we discussed today. As today I started decision tree, and in automotive analytics course, today is the 6th day, and we discussed already regarding applications of this industry and project management methodology. And this project management methodology, it has 6 steps, starting from the business understanding and data understanding, and second step data engineering. So data engineering also nothing but EDA and pre-processing. So that part is very important. So we can, while simply if we have the data, instead of going for the next step, so we need to clean the data. There will be some NA values and outliers, so that we discuss it clearly. with respect to one use case. So then discussed about types of machine learning. So as we discussed, machine learning is classified into two types. So like supervised learning and unsupervised learning. And we discussed unsupervised learning. So where here we not having any output variable. So prediction, it is just on unlabeled data. So it will give unsupervised learning will give rules and patterns. And we have various unsupervised learning technologies. We use k-means clustering. So we need to decide k value, and k value we can calculate by elbow method. And after we can segregate data, we can find the different clusters. So when a new data point is comes, we can find. So in automotive industry, as per we can split into the various clusters. When new, if suppose the vehicle is releasing some that percentage of pollution, so it is working with that efficiency. So we can categorize by using clustering. Then we started supervised learning. As we discussed the supervised learning, so learning in with respect to the supervisor. So here the learning is done by comparing the output. So there will be features. So for the features A, B, C, D, so let us take some features A, comma B, comma C, D. If for the particular feature, the output will be 1. And the machine can learn the output for the various features. Now, when we enter new data points for the particular data points, so it can predict so what will be the output. And as we discussed it today clearly in supervisor learning, so supervisor learning again classified into two: regression models as well as classification models. So yesterday and today discussed about k nearest neighbor, and today we discussed about decision tree. So both comes under classification model, and today we discussed it. So what is decision tree in supervisor learning? So it is decision tree is one of the supervisor learning technique, and it is used for both the classification and regression problems. So classification, nothing but it will split yes or no. It will classify. And as I'm saying, it is mostly preferred for solving for classification problems. So it is why it is called a decision tree, because it is similar to the tree. It starts from the root node and expands. So based on the branches, based on the decisions. And it will form rules based on simply ask the question, and based on that yes or no, further it will split. How we can how decision tree in how it will work in machine learning. So predicting the class of the given data set and starting from the root node and compare the value, and based on the comparison follows the branch or jumps to the next node, and usually mimic human thinking ability while making the decision. Same how we will take our decision. So either I need to attend today's exam or not. So first thing is are you interested in let us some factors. So am I free at evening? Suppose 6 o'clock I need to attend examination. Am I free at 6 or not? Suppose if no, then simply I can say I cannot able to attend. Yes, this exam is about what? Is it related to the machine learning or other technology? So I am not having idea in other technology. I have knowledge in machine learning. So yes, with respect to machine learning. Yeah. So in this way, how we are taking the decision, same way it will work. And logic behind the decision tree can be easily understood because it shows tree-like structure. And there will be some terminologies in the decision tree classification algorithm, like decision node. So the another name for decision node is root node. And tree subtree. So subtree is nothing combination of again decision nodes and leaf nodes. And today I have explained so why do we need decision tree in automotive industry. If you want to purchase car, we can take our requirement is this one. So based on our requirement, they can suggest this is you are looking for an etc. So instead of taking the manual decision, so generally make decisions manually. It is a time consuming process and labor intensive process. So it should be done by the decision tree. We can overcome that. And evaluating the conditions of the car before purchasing plays a crucial role in decision making. And as per the information, so vehicle there is 1,000 parts for assembling good accuracy should be taken. And Toyota Innova takes 1.6 minutes of time. So by using machine learning, and we can leverage machine learning technique to develop an automatic system for automobile evolution. Yeah, finally, it is used for classification. I'm predicting, and it can handle both data. Okay. So thank you, friend. Thank you for joining. So we have finished decision tree today. So classification models and supervised learning is finished. So tomorrow we will discuss about regression and what is regression, what are the types of regression, how the regression plays an important role in automotive industry. We'll discuss tomorrow. Okay. Please subscribe our channel. Thank you. Have a nice day.